My name is Sarah Fisher. I am a sophomore in computational biology, and I am involved in TartanAUV, which is our Robotic Submarine team, as well as SCS Student Advisory Council and other miscellaneous activities. Yeah, so I'll be talking mostly about RoboSub, which is our autonomous submarine team. We compete every year at an international competition, and it's a lot of underwater autonomous tasks. So the sub is by itself, running into buoys or like shooting torpedoes and dropping markers on different locations. And so there's just a lot of like miscellaneous tasks that they ask the sub to complete all on its own. So I work mostly in perception. So that is the software side of the team that detects different pieces underwater, like game pieces, be those like the buoys that we have to go run into, the gate that we drive through, the little bottles that we pick up, stuff like that. It was my freshman fall, so I had just gotten to campus. I made just a couple friends in the School of Computer Science, and we were looking for a robotics opportunity here, and someone found RoboSub, and it was just at that point 2 seniors that were like not even invested anymore. Everyone had graduated and they were left alone, and we just jumped onto the project and we were like, we're here to help, and we are so ever since there's just been a group of what were freshmen last year and the 2 seniors that graduated, and now we're leading a legacy. Like, yeah, continuing the team. I think that it's really nice to have a team here on campus. When you're in high school, you have like a lot of different teams and you're involved in like sports and other activities, and sometimes in college it doesn't always feel that way unless you seek it out. So I'm really happy that I have a team surrounding me, as well as I have an opportunity to use what I'm learning in class in the real world. Like, I'm really applying the computer science that I'm learning in all of my classes to something that's like tangible and really fun. So I actually had never programmed before college at all. I had zero background in computer science, and I just thought that it would be something that I would be really interested in because I really like problem solving. So I applied to CMU SES and I was accepted, and I came to campus. My first code that I ever wrote was in our introduction programming class, and I had never also encountered robotics, but it was something that I was super interested in doing because I had seen so much, and there are a lot of like other high school kids that had done robotics, and it's like a large field and large application field for like activities. So when I was like invited to join this team, I was super excited to do so, and I again like learned everything on the fly. Like, I could never have written any of this perception system like a year ago, but now I've just like really picked everything up and it's really fun. There was somewhat a working system when we all joined the team, but we kind of just redid everything. And so there were like 6 of us that kind of just divided up the sub into little subsections. And I like got the like close range perception tasks, which is like isolating bottles from their background to grab them with our like grabber, and other like traditional computer vision that is like isolating things from foreground and background and being able to like locate them in space. But there's other parts of the software team, and one of those is controls, which is like moving the submarine in the water. Another one is navigation, which is like knowing where the submarine is in space underneath the water so that we can like navigate to other locations. And another one is having all of the things that we've ever seen underwater in a 3D map so that you can like navigate to those things and know where they are in space. So all of those parts kind of work together on the software side of things, and obviously we all help each other, but we each kind of just like dive into our own like individual problems and collaborate on like making it a system where all of those pieces can work together. The first main problem is that we have to waterproof our sub. None of our electronics can get wet, and that was a big issue early last year. Like once you get it right, you get it right, but it's like a lot of trial and error just to make sure that your sub isn't going to go into flames underwater. Secondly, there are lots of times when you're working with land robotics, you only can move in like 4 degrees. You can only move like forward, backwards, side to side, and sometimes you can jump up and down. But when you're working with a submarine, you can roll, pitch, yaw, so that there are like many different ways that you can like rotate your vehicle. So like learning to navigate or like being able to like use those different degrees of freedom is also something really like a very interesting problem that only really comes up like in an underwater environment. As well as sometimes the computer vision, like being able to see out of your camera and locate things, is more difficult underwater because of the water being there instead of just clear air. And but a cool thing that comes from being underwater is that we can use acoustic systems to locate things. In air, that doesn't really work, but in water, if you send out like pulses, you can like echolocation like a bat. Like it can bounce off all of the items and like tell you where you are in relative to other items. And that is like a very cool thing that we're exploring this year in our underwater environment on the submarine. So one of the biggest challenges is when our submarine will often there are just like lots of problems that you can encounter and like run into when you're like testing really frequently. So when we like went to the competition last year, it's a week-long competition and there's rounds of like finals and semifinals and like up until like you have to qualify to. So there's just like with that, we were in the water like every single night, like water testing, and there's just like it's really easy to like break a very complex system. So some of like the challenges that we faced at competition were things that we would never have expected to like run into, and we had to kind of solve those problems on the fly and like really like come together as a team. And it was like a really great bonding experience. We'd have to come together as a team and like solve these like either mostly mechanical, but sometimes like electrical, and sometimes the software would break, and it's just like all hands on deck on like fixing those problems that we never could have like expected to encounter. On a large scale, our team is split into a mechanical sub-team, an electrical sub-team, and a software sub-team. And I kind of have talked about that software side where we have like perception, controls, navigation, like all of the autonomous underwater tasks. But there's also a mechanical team that works to like print all of like 3D print or design and manufacture all of our other like components. Like we have a marker dropper and we have an arm that can like grab items underwater, and like our entire submarine for that matter was designed by our mechanical team. And then there's an electrical sub team that works on like making sure that all of the electronics on our sub are working and that everything is connecting and can talk to each other, so that the software can work properly. I am the least familiar with the electronic side of things. We have a couple really great electrical and computer engineers here at Carnegie Mellon that are working on that sub-team. I'm the least familiar with that, and your background would really have to be with electronics to be able to like understand that side of things, I think. But the mechanical side of things I've dove into a bit, and it's really like lots of those people have like their only experience with like mechanics is on like high school robotics teams. One of the major contributors to our mechanics team is a computer science major here at CMU, but did design for his high school robotics team. So really, if you can use some 3D printing software and start designing things, you can really hop on a project on a mechanical side of things. And with software, like I said, I had never really had a lot of experience with software prior to coming to CMU, so it's something that's really accessible if you're really interested in computer science, no matter your background. So robotic submarines are like a really niche area of the robotics field in general. But I know that the competition that we attend yearly is under this umbrella that's called RoboNation. And RoboSub is directed toward university students, but there is one high school team that does really well every year. But there are other competitions that they host that are water-based. Some of them are like boats, and I think that there is another submarine competition that are like aimed toward like high schoolers and middle schoolers so that everyone can get involved. But also, if that is like really inaccessible, I just think that getting your hands on anything robotics based is a really great start to getting involved in robotics submarines, because I never would have expected to be here myself building an autonomous submarine. So I just think that any exposure that you can get to robotics is really, really good, and you can always apply that to a submarine in the future if that is ever something that you would be interested in doing.
Mm-hmm.
I think that computer science is a really, really broad field, and you can get very invested in like little areas of it. Like, apart from being very involved in our like robotics team here, I am a computational biology major. I plan in the real world to apply computer science to like biological problems instead of like robotics problems like I'm doing right now for fun. So I think that when you're trying to explore computer science and you want to make a career out of it, finding something that you can apply your computer science to that is really important to you is something that is like very important to like being happy and like having a really successful computer science career.